magnetic field of a bar magnet or a dipole magnet on its equatorial line. So equatorial line means suppose it has an axis at the center. This is the south pole, this is the north pole, this is the center, and at a point on this axis, this point is P, and we have to find the magnetic field at this particular point. So suppose this distance is L and this distance is again L, the center point. So the distance between two poles is 2L. This particular point P is at distance R from the center, right? So we just join this points P and S and P and N. Therefore, this particular distance S and P will become root over R square plus L square. Same way, this distance also will be root over R square plus L square, right? So this is L, this is R, so this is root over R square plus L square. This is L, this is R, so this is root over R square plus L square. Now we need to find what would be the magnetic field at this particular point. So suppose the magnetic field due to N is B1 and this field is going in this direction, right? Due to this south pole, the magnetic field is B2, suppose, and this is going into this direction. So we have to particularly find what are their vector quantities, in which direction we have to see, and then we have to calculate. So if this is B1, I can split it in two ways, this like this, like this. So suppose this angle is theta, then we can say this angle is theta. So if this is B1, this side will be my B1 cos theta and upward will be my B1 sin theta, right? So I will just clearly again show that if this is B1, this is theta, this is B1 sin theta, and this is B1 cos theta. Same way, this with S to P, from south pole to P, we have B2. So B2 is going like this. This is B2. Then we can again say that this is going like this. But since this is south pole, it will be towards this direction. So you can write it in this direction. This will be B2. South pole means it will be in this direction. B2 will be in this direction. So if this is B2, then you can say if this is theta, this is B2 cos theta and this is B2 sin theta. So you see B1 sin theta and B2 sin theta, they are exactly opposite direction, right? Whereas B1 cos theta and B2 cos theta, they add up, they are in the same direction and they add up. So first let's see what is B1. As we already know, due to a particular pole at a distance, this distance, what would be the magnetic field? Now if the pole strength is Qm, so we know that B1 will be mu naught by 4 pi Qm by this square. This square means R square plus L square, root and square. So this gets, root and square gets cancelled. So this is my expression. Same way, B2 is again mu naught by 4 pi Qm R square plus L square. Again root gets cancelled and the square. So what we see is B1 and B2 are almost same except the directions. They are same in quantity. Now therefore B1 sin theta and B2 sin theta, their magnitude will be same but exactly in opposite direction they are working. So they two cancel each other. So what will be the resultant magnetic field that is effective? The resultant magnetic field B, which is effective, which will be B1 cos theta plus B2 cos theta. So only the cos theta part they gets add up, and only that part would be the effective magnetic field B. So we just substitute this, and then we will get, since B1 B2 both are same, so we can write 2 mu naught by 4 pi qm by r square plus l square cos theta, right? And here we will just substitute plus by for cos theta. See, if this is the angle theta, so I will draw it here. If this is the angle theta, then this, for this particular, this is angle theta, this is L, this is R. Then from here you can write L by root over r square plus L square, right? So you can write cos theta as L by root over r square plus L square. So I will substitute here. This expression will become 2 mu naught by 4 pi qm r square plus L square into cos theta is L r square plus L square power half, right? So this whole expression will become B equal to mu naught by 4 pi qm into 2L, and half plus 1, this will become r square plus L square 3 by 2. Power 1 plus power half, this will become 3 by 2. Now again, very interestingly, this part you see, this is nothing but qm, the pole strength, into the distance between two poles, that is 2L. Therefore I can write it as mu naught by 4 pi into m, where m is the dipole moment, and dipole moment we know, dipole moment m is the pole strength into the distance between two poles, that is q1 into 2L. So this is the same thing that we are getting. So we are substituting it with magnetic moment divided by r square plus L square whole power 3 by 2, right? So this is the magnetic field B. So in this case also you can actually tell that R is much greater than L. Therefore, because the these magnets are small and its length is very small, therefore the R will be much greater than L. Therefore you can neglect this total L part and you can write as B mu naught by 4 pi m r square, and this one gets cancelled, so you can write it as r cube, right? So this is the magnetic field B due to a dipole magnet or a bar magnet on a point which is at equatorial line.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.